Hello, hello. It's me again. We continue our Mobile Z Days conference, or to be more specific, uh, we continue our Flutter Z Day. And this is time to second talk of this day, talk about testing of Flutter application. Please meet open source enthusiast from India, Google developer expert in Flutter and Dart, Burhanuddin Rashid. Welcome.
Thank you, Alex, for the introduction.
Hello, Burhanuddin. Thank you for joining us. Hope you are doing well. Could you tell how long have you been developing on Flutter?
So I started my Flutter journey 2 years back. So when I was looking for some cross hybrid solution, I just started exploring Flutter, and then the journey continues after that.
Yes, it's a lot of time ago.
Yeah.
Okay, I think we can start your talk. Let's go.
Yeah, sure. Okay. So hello, everyone. My name is Burhanuddin Rashid, as Alex has introduced, and I'm software engineer at Sahaj. And today I'm going to talk about testing in Flutter in real world. So I'm assuming here that you have been working on Flutter for some time. You are building some UI. Now you want to write your test in Flutter. So basically, you have an existing code base and you wanted to write tests. And this is the best way to understand how you can start writing your test in Flutter. So here, what we are going to learn today: why we need testing in the first place. How can we get started with zero test, basically with a legacy code, and type of testing in Flutter with some demo, and some quick intro into some few CI/CD solutions. So let's understand why we need testing. We need testing because of this. Because whenever we release an app, we don't want to be in this situation, like praying all the time that we don't break anything major. So this is me every time deploying to production if I don't have any test for Flutter. So jokes apart, why we actually need testing? Because we need to have a better user experience. We need to have a frictionless releases so that our user doesn't face any unexpected behavior. It doesn't see any big crashes. So testing will help us to catch bugs very early on, and it will provide a seamless user experience. Now, the second thing is refactoring, and the majority part of testing is done because of refactoring. So as Martin Fowler said in his book, that if we want to do the refactoring, the essential precondition is that we have to have a solid test, because solid test here work as a safety net for us, because whenever we refactor a code, there are chances that we are breaking something. So whenever we refactor code, we run the test, we check if we are nothing breaking, and we are preserving the old behavior. But if we don't have a test and if we refactor, then we have to manually click on that screen, the button, and verify the text, all that, those manually. So which is sometimes very time consuming, and if some human is involved, then it might lead to some error in testing. Now the third one is basically generating more revenue. It sounds a little counterintuitive in first, because in order to write tests, it takes times. But in our software industry, if something takes times, it costs money. But in our case, in writing tests, it's opposite. And it also ties back to the point number one, with a better UX. If you have a good user experience, user will stay on your app, it will share with their friends, and more people will be coming on your app, and you will have more revenue. But testing in real world is nothing like this, because this is something what happened. I don't always test software, but when I do, it's always in a production. So I was working in one of my company, and there was my colleague. So one of our clients suggested to do some changes in the production app. So instead of my friend, what we did, instead of creating a Jira ticket, writing a description, following the workflow, he directly went into the production PC remotely, changes the code right there, hit save, and refresh the server and see the changes if it's working or not. So that's how people usually test in a real world. And why this kind of things happen? Because currently we are living on a world, in a startup world, where we want to build everything fast and we want to ship as quickly as possible. And Flutter is a framework which is known for its development speed, so that you can build things very fast on multiple platforms, and it also helps to validate your idea very quickly. So in order to launch launch app very fast and build very fast, we don't get time to write the test. So that's why measure of the app don't have tests. And most of the time that it's very rare that we get to work from a code which we need to build from a scratch. Most of the time we worked on existing code base which is written by someone else, and they also went through the same thing which we are going through, and they don't write tests and we face the same thing. And in my consultation experience, I have been part of some Flutter discussion. I have seen that some of the startups have very good architecture code and they structure very well and naming convention and all that, but they don't have any test. So I see this more often. So now the question is, how do we get started with zero test? If I have an existing app, and if I want to get started writing tests for it, how do I do it? So the answer of this question lies that how many types of tests are available, and based on their pros and cons, basically advantage and disadvantage, we can choose what to start with. So initially when you start with, there will be a lot of jargon words like smoke testing, insanity testing, interface testing, integration, beta. There are so many testing out there. We are not going to talk about all those things. We are basically kind of talk about three types of testing which are there in Flutter. One is unit testing, one other is widget testing, and there is an integration testing. So unit testing is nothing but basically testing your each function, method, or class. Like if you have a form and you want to validate that form, you have a function validation, and that validation function is very good candidate to write a unit test. If you are fetching data from a backend and transforming into a UI model, then that transformation function is a very good candidate for writing a unit test. And widget test is nothing like if you have worked on a React, basically like a component, a small set of a UI element where it displays what you expect, and it also displays the update when a user tab or basically if you do some navigation, gesture navigation on it, clicking on it, or if you want to change the text or color or anything, you just test that small component. And integration test is nothing but mimic the real user on an emulator or real device, basically clicking on the button and all that. So when we start type of testing, we see this pyramid. And this is the standard pyramid we see everywhere, where it says that you have to have less number of integration tests, moderate number of widget tests, and more number of unit tests as much as possible. The reason why is because integration tests are very slower and more expensive because they require the emulator, all the UI setup and all that. And unit tests are much far cheaper because it just tests your business logic and it's purely based on your language and stuff like that. So this standard approach works fine when you already have a good test in place, the project you are working on, and if you are following a TDD practice from the beginning. If you are starting from a project where all these things are already there, then it's very easy to maintain this pyramid structure. But if you are working with a legacy code which doesn't have any test, then to write more unit tests, it's very hard to write, and it's also very time consuming because your app is not structured in a way that you can write a unit test for that. And it also provides less confidence because if you are able to write a unit test for 1 plus a plus b is equal to 2, but whether you are not sure it will be integrated on a calculator app properly if you press 1 plus 2 is equal to 3. So what is the way to do this? What is the solution? So basically, this is the way. I hope you understand what I'm trying to say here. So basically, we are going to flip this triangle for a legacy code that have more number of integration tests, moderate widget tests, and less unit tests when you're working with the legacy code. The reason why is because integration tests provide high confidence because it's very close to a real user, what your real user sees. So it's provide very high value for that. And unit tests provide very low confidence because it's nowhere near to your real user. It just tests your business logic. So let's start with integration testing. So why we choose integration testing for unit testing because of this. Here the units are working fine, but the integration of door is not working. And this is my favorite one, where the umbrella is working, but not fully integrated. So in order to understand integration test, we need to have some sample app, which is our what to do app. So I started building this app 2 years back, where I was getting started with Flutter. And this app is nothing but a to-do app, which helps to add task, add project, then add task to it and assign a project to it. We can sort and filter based on time, project, label, and it's also allowed to swipe a task to mark as a complete, and also left to right to delete this task. So we are going to do integration testing using a Flutter driver, which will run on a real device. It runs on a separate process. So the test which we are running, it's run on a separate process, and the APK which run on a separate process. This is an important thing to note. I'm going to explain that in the demo. And it's a similar tool like Selenium for web, Protractor for Angular, Espresso for Android, and Early Ray for iOS. So now let's jump into the demo. So I'm going to show you a demo. Yeah. So in order to write a Flutter driver test, first you need to go here a pubspec YAML file. This is my what to do app, which already have existing code. So you need to go into pubspec YAML file, and you need to add this Flutter driver here, and need to do a pub.get, which will fetch all the library necessary for this Flutter driver. Then you need to create a test_driver folder here, and then you need to create a two file, home_page and home_page_test. You can name this anything, but you need to remember that you append _test.dart file where all your tests will reside, so that whenever you run a command, it will pick up this file. If you don't define this file, it will say file not found. So basically this file works as our entry point. So this is nothing but a void main function here, which we are defining that we are enabling Flutter driver extension, which says that this APK will run as a Flutter driver extension. So we are going to run a test. And then we define an entry point here called app.main. And this app.main is nothing but our Flutter app, whole app. And this is the homepage.test, where we are going to write the test. And this test will run with this entry point. So let's write some test. So in order to write a test, I'm going to use a group. So basically group nothing but is logically groups your test which have the same contacts. And I'm going to create this here. So in order to write a group test, first we need to set up a Flutter driver, which will help us to interact with the app. So I'm going to set up my driver here, and I'm going to just import this. Now here setup all, basically I'm going to connect this app here and close it when it's tear down. So setup all runs per once as a group, and if I do setup, it will run for each test. So this is how the driver works. Now let's write our first test. So in order to write our first test, the basic test we could start with is just a test which whatever we display first on the app. So here is the app. So whenever I let me just delete this. So whenever I launch this app, I see no task added here, and I see the title here, which will be today. So I'm going to just stop this, and when I start this, you will see that there will be a title called today on the above, and here is a no task added. So we can simply write test for that. So whenever we launch app, just test that. So what I'm going to do is I'm going to write a test here, and in description it will be today in title, and then I'm going to write sync just because we are going to use a driver here. The first thing we need here is to find this title. And how do we find this title? By using a widget called find dot by value key. So here we define a key to find. So when I started the test, there was no key defined, but as initially when there was no test, there was no key defined. But as I started writing tests, I defined that keys to each widget which I required, and then I move into the constant file. So to keep it maintainable, so I'm using that constant file here, home page dot home title here. So if you see the home title, this is the key, and it's been used in a home.file text here, and it's fetching that title. And now I'm going to have this home title here, and then I'm going to expect I'm going to expect that driver to find that text. Using the driver, I'm going to get that text using that home title matcher, and I'm going to say let it be today. And this is how I can write the first test. I will copy the same thing, and I'll just do the same thing to find the text for the message in center. So it is the key here, the message in center. So I'm going to change that. I'm going to pass this here, and instead of, let's just have, I'm just intentionally misspelling the thing so that at least one test pass, another fail, so we can see it's working fine. And now I'm going to use a Flutter command here, which is nothing but flutter.dive target homepage, which is this, and it's going to run test for that. So you see, when I'm running the test, it's going to take, the tests are very slow here because it's going to assemble the APK, and then it's going to uninstall the previous APK, then install the other APK, then it will run the test. So this is the biggest disadvantage of integration test, that's very slow. But the biggest advantage of that is because it's testing a real user. As we see that it's testing the whole starting screen of your app, where we have a today, no task added. So it's basically testing many components all together. So you just write one test and you are verifying so many things. So I hope the test runs. So currently it's building the APK, and since we don't have APK, it's taking too much time. I'll just wait for a few seconds. If it works, then I'm going to move with another test. So this test would basically pass because this will basically fail because the task.edit is not working here. Now another test we could write is here. Like if I'm clicking on here, I just want to sort this inbox today, next 7 day based on that task which we are providing. So we can do that. I'm going to just write a test here, another test, and I'm not going to spend much time on it. So I have written this test, and this test doing nothing but first it's finding the value of home title here. Then I'm just providing a future delay in order to initially load that, and I'm just clicking on a drawer here. Then I'm clicking on it today, and then I'm just verifying the text. And when I click on a today, I'm just finding this task.title1 and project.title1. Now you might be asking, what is this task title underscore 1 is and task project underscore 1 is. So basically these are the items which are displayed here, and we are picking each value from that. So this is are the key which we created dynamically. So let me show row underscore task here, and you define task title underscore ID here. So I'm just adding this dynamically so that I can find each element in this list, and then that each element I just verify this with task 1 and inbox. And same with the second item in the row with task title 2 and this. But if I run this test, it's going to fail because it doesn't have this values in it. So there are two ways to do that. One way we can do is we can write a test for clicking it here and manually adding different tasks, and it will just show up here, and based on that we can filter them. But in order to have those scenarios, there will be multiple ways of doing it, and there will be a lot of tests here. And already this test is very long, and it's not a good way to structure it. So how do we test that? The second approach would be that we need to have some mechanism when we have a pre-populated database here already, and then we can just write a test against that. But so you might be thinking, okay, if I want to put some data in test data directly, I will access the app database here and put the value directly here and run the test. But this is not how integration tests work. If you try to access any Flutter UI framework code here, then this test will fail, saying that saying that you cannot access the Flutter UI framework code here, and it will fail. So the only place you can access the UI code writing the test is here homepage _dot. And here we are just using the main app here, and we can use the Flutter UI widget, whatever code we require here. So we need to set up some communication between them. So how do we do that? We can do that using data handler. So I'm going to use a data handler here, which is nothing but a function which take a message as an input event, and based on that string, we can perform some operation. So here I'm on add data, I'm adding a data, and on clear, I'm clearing the data. So I'm going to just seed some data here, and I'm going to import all those so that it will work fine. So here how I'm running it, and it will clean the DB whenever I get this event, and this will clear the data when I will get this event. And now we'll pass this handler to this data handler here. And now when we come to the test, what we are going to do is I'm going to just delete this. And after I get connect, I'm going to pass that event to the main app, and I'm going to create a request data, and I'm passing the key add data here, and I will just copy paste it here, and I will just say clear data. So when I run this test, it should pass. Let me just try one more time. It works, then it's okay, else I'll leave for that. So this is how you can write a test for it. If you want to have some more complex test where I'm just clicking on the button, navigating here, swapping it, going to multiple screens. So I have written those tests. So you can just check out my repo. It's open source, what to do app, and there you will find that different kind of scenario and very complex scenario. So I think there's some issue. I'm just checking if the internet is slow. No, it's fine. Something is broken. Anyway, so this is how you can do the testing. So suppose there might be a scenario where you want to just test a single screen. Like if you are just clicking this about, this is just a single screen. So if you want to, this doesn't depend on database and anything, just an independent screen. So what you want is you don't want to load whole this app. Instead, you just want to load only this part and run the test against that. So you can do that. You can I go to reset it, and I'm going to check out the final part of this. And you see that I'm creating two pages, about us page and about a test. So about us page is nothing but the similar kind of thing, but instead of main app, I'm just running the material app with the about us screen. So basically it will run only this app, and I'll write a test against that. I will just find all those keys, and I'll just expect that with all those. So this is how you can just test an individual screen if it's independent from anything, and you can just mock specific data for a specific screen. You can also, just since you see that I don't define any theme, you can also test by providing different color here and just test your theme here. So this is now about the end-to-end integration. Let's get back to the slides again. So here we did integrated test with Flutter driver. Unfortunately, the APK was not running. It's stuck because of some issue. So the advantages of here is that the confidence is very high. We run a bunch of few tests, and we cover most of the major area of that. It's very closer to the real user, like clicking and navigating, which I was showing, and it catch major bugs very early on. And it's easy to write after the fact. Like you don't need to change much of your code, existing code base in order to write this test, because you just find the widget and match the text. Currently, the API is limited to just match a text. I hope it will get better in future so that we can match specific color and all that. Now, the disadvantages, the execution speed is very slow. As you have seen and witnessed that it's very slow to run the test. It required Flutter SDK, Android SDK, emulator, many things. So it has very much more dependency. And because of that, the maintenance cost of the integration become very high. So the thing is, you just start with the integration test. When you have a good test in place, just refactor your code and then try to reduce the number of integration tests and increase the unit test. So the key things to remember from is that you need to append _dot file in order to pick up that class as a test. And the Flutter UI framework cannot be accessed in the driver test. That can be only accessed in a homepage.dart, where you basically have defined your entry point, or where this file you pass is in command. And in order to communicate between those two, you use a data handler for that. And if your tests are slow, then you can use a desktop app in order to make that fast. But if your app is dependent on something platform specific, then it would be very difficult to run on a desktop app. So you need to think of something else for that. So let's go to our second type of testing, widget testing. Also in a React word, it's called a component testing. So the widget testing, nothing like test a single specific UI element. It's like a UI testing because it verifies look and feel of your widget, the color, the space, the size, and all that. It's also verify the instruction and updated as expected. Basically, you tap on something, the text is changing, the color is changing, the alignment change or not. So you can do this type of widget testing using that. So in order to understand widget testing, you need to understand the app structure, because you need to know where the widget lies in the hierarchy, what kind of dependency it has, and what kind of structure they are put in. So the app structure is basically a block pattern, which is nothing but a business logic component. It's basically a separate class where you define all your business logic, and it doesn't have any Flutter UI framework related code. You just expose those stream to the Flutter, whoever creating that block, and the UI code will listen to the stream. Any updates are there, and they will update their widget accordingly. So this is how the what to do app is structure. Let's go one by one what it does. So here we have an app database, which is responsible for creating the database singleton database instance. It handles the create, update, and migration function. And then this class is injected as a dependency on these three: label DB, project DB, and task DB. So these three classes are defined based on a table, so that it can group logically all those query related to that table. And these classes are injected into specific block. The block can be anything. It can be based on features, based on screen, based on table, anything. There's no hardcore rule for that. So here we have a add task block where all those threes are injected in order to create a new task. And then we have a home block, which is independent from this. Basically, it's defined on the top of its parent, and it's passed down to its children, so that if any children is listening to that home block, it can pass event to the another children. Basically, it's work like an event bus system to pass event around the app. So this is how the app structure is. Now let's understand the block widget relationship here. So this is how the relationship is defined. On the top, we have a home page where we define the home block, and then for each task we have defined it. There are different block, and each will have their own block there. Same for the add label and project block for that. Now this home block which we have created on parent can be passed down to the side drawer, or it can be also passed down to the new project page and label page. Same thing here. We created a block, label block, and project block here. We can pass down to add project or add label project. So this is how whole widget relationship has been defined and what to do. So let's see some quick demo. I hope this time the widget test works. So So this is our app. Now I'm going to go back to the talk demo. And in order to write a widget test, you need to again go into Perspec YAML file. You need to add this flutter_test and just get it. And then you need to create a test folder. In that test folder, you create a file with _test convention. The same thing here. You need to follow _test in order to pick up that file as a test. So basically, widget test is nothing but testing a small component. So we are going to use a test widget here. So what we are going to test is we are going to test a project row here, a single row. And then in this callback, we are going to get a widget tester, which is a helper class, which help us to run that widget in the test. So this is how we created the test. So basically, we are testing this single block here. So we are going to test whether it's showing the text properly, the color here properly, and the space around here properly. So this is just a single test here. So first, we need to create a project row here. And this project row requires a project Pojo. So I have just created a test data for that. So I'm going to use that test project here. So if you see this test project, it's nothing but an data which we are creating here, dummy test data. And then I'm going to create an instance of that project here. So that's done. And then I'm going to use a tester method, await.tester method, which will pump this widget into the test so that we can run test against that widget, which is pumped. Now it's pumped. And now the first thing we need to verify is whether we are showing this text properly or not. So we are going to expect, and I'm going to find a widget of that same text. So I'm going to use this project.to, and its project name should have at least one widget. So this is nothing but finding a one widget in the hierarchy and just verifying that test. If you want to find multiple, you can just use n widget and define a number. If you don't want to find nothing, you just use find nothing. But in our case, we need at least one widget. We need to have that one widget in the tree. So if I run this test, then let's see what happens. So the test failed, saying that the block is null. So let's see why it's null. Because when we go into the project, we see that we are accessing the home block here, which is coming from its parent. But since we have not defined any parent here, it's not able to get a home block and it's failing. So the one way to fix this, we need to wrap this into a block provider, and we create a home block here. And we are going to import this block. And then let's run the test again and see what happens. You see, in order to run a widget test, it doesn't require any emulator. It just directly run like a unit test. So if we run this test, we see it fails because it says no material widget found, list style required, material insister. So if we see in the project row, we are using a list style here, which required a material ancestor because this is defined based on a material theme. So we are not having that ancestor, because of that it failing. So now we can do is we can wrap this inside into a material app. So we can do that. But you can see that the whole app run on the material app, and many of those things will anyway required, and also the block. So I have created a handy extension method for that, so that I don't have to repeat those things again and again. So you can create some helper extension for your test as well. So I'm going to wrap this into scaffold. I'm going to provide a home block here. So if you go into this wrap scaffold widget, you see it's wrapping the material app, scaffold, and a provider here. So it's saving a lot of duplication work. And then if we run the test, I hope it should pass. Now we are running the test. And we see it passed. So here it's able to find this widget. Now let's just find this circle widget and match the color, whether it's showing properly or not. So I'll go into this project row, and I'll try to find out where that widget is. So this is basically the circle avatar, which we have defined the value, where we have a dot, project name, and ID, so that we can identify this through that list. And then we are going to match this background color, whether we are showing properly or not. So what I can do is I'm going to use a tester class, and I have created a function find widget by key, and I'm going to use that key dot underscore. Our project name is personal, and the ID is 2 here. So we need to find that. We need to also provide what kind of widget we are searching for. So we are providing circle avatar here. And then I'm going to create that circle avatar. And then I'm going to expect that circle avatar dot background color should match whatever test project dot to color value is. So, and this find widget by key is nothing but finding a widget by key, whatever key I'm providing as a key, and just finding the first widget in the widget hierarchy and casting into whatever type we have defined. So if it's find it, it will pass, otherwise it will fail. So let's run this test again and hope it should pass. So now it's running, and we see it failed. Oh, okay, it's failed because we are just matching the color here. We need to find a value here, and then run this test again, and hope it should pass. So it passed. Now we can just match the space here. So we need to find how we are doing that space. So basically we are using a leading container here with the width 24 and height 24, and providing a key space with the same pattern, name and ID appending in the end. So this is providing an empty space without any background. So we need to find this widget and run the test against that. So what we are going to do is we are going to use directly expect. I'm going to write that. So I'm just finding this widget using this key. I'm matching the max height and width here. So let's just make this as a 26 so that we know that test is failing. I'm not doing any trick here. So this should fail. And we see that here we are expecting 26, but it's 24. So let's just make it 24 and run the test. So now it passed. So now we have tested the whole user interface, how it looked like. Now we need to test some navigation. So like whenever I click here, then it's update the title here and all the tasks by that filter type. So how can we test that? So we can test, I'm going to write directly that test, project tab here. So what we are going to do is, instead of testing whole this screen, we are not going to test whole that. We are going to just test the event if the event to the home block is passed this personal and this type of filter correctly. So what we are doing is I'm just creating a project row tab here. I'm just creating a home block here, and then I'm wrapping this into a project array. Then I'm pumping it into a tester widget. Then I'm just verifying this title stream in order that it should pass at least a project name, which is here, and also a filter by project type, which is this ID, so that I can understand what kind of project we want to filter here. And then we are going to call tester.tab. I'm going to find that value personal to this key is basically nothing but this whole key. And then we tap on it. This test should pass. So when we tap on it, it emits that item, and this checks the item in that order. So we are running this test, and it passed. So here we are just testing the stream. You might be in a situation when you are just tapping it, you are just testing the changing the text within that widget itself. Like if you are changing this personal to persons or something like that. So if you do in a click here, in Flutter APK UI framework, you click here, it will automatically refresh the widget for you. But in test, it doesn't work that way. You have to manually pump your widget, which is basically a refresh of widget, whenever you do some interaction and expecting something to change. So you pump this widget and run it after that. About find it questions section, or you can just so let's get to the slides. Widget testing, we have used widget tester. Advantage of pros, basically it's very unit test because it does not require any devices, and it's very good for fast work. And we focus on a small component look and feel instead of a very big thing. The disadvantage is the dependency, as we see that it required a home block and then it required a material app. So you need to wrap whatever dependency it has, or you need to find some way to pass those dependencies into it. You need to use more mock and fake for that. I have not shown an example, but you will definitely find in my repo. And you actually don't see a real design here, but you can fix by using a golden test. So golden test is nothing but it takes a screenshot of your widget UI, and then whenever you run a test, it match the new UI in that test to the previous one and say whether that are same or not. So the key things to remember is in a parent widget, wrap what is required. That means if you have a widget which is 10 level deep into your hierarchy, but it requires only 2 dependency above that, then just wrap into that 2 parent widget. Don't try to wrap into everything. And try to avoid unfinished stream so that the test can pass. If you provide unfinished stream, the test will wait for your stream to get completed, and it will be stuck forever. And use find widget API to match your UI. Basically, find one widget, find 2 widget, and find nothing like that. And you need to understand difference between fake and mock when you want to use a fake and when you want to use mock while using widget testing. So now let's go to the unit testing, which is our last part. So unit testing is nothing but basically testing your business logic, app logic, nothing related to Flutter framework or something. It's based on purely Dart thing. It's verify your function, method, and class, and it does not test your actual user interface. It just purely tests your business logic. So let's go into the demo. I'm going to open this. I need to reset, need to clean the previous mess. I'm just cleaning it. Now, in order to write a unit test, you go to some YAML file, you just test any, and if you want to use a mock, then you need to have this Mockito library, which is a very good tool to mock, and it will save you a lot of time. Then the same thing here in underscore test, you create another file, home block test.dart, which will just work as your test class. And then in void main, you will just write a test for it. So what test we can write here? So in a unit test, as we say, it doesn't test any Flutter UI framework. It's basically test your pure Dart-based logic. And in our what to do app, the blocks which we have defined are pure based on Dart. So we can start a simple test with the home block. So let's see what home block has. So when we go into the structure, we see we have a title here, which exposes the string as a title, and we have a filter which defines the type of filter we want to have. So we can write those tests whether it's showing the title and filter property properly, because this title is updated when we call update title method, and when we call apply filter, the title and filter is get updated. So let's just write a test for that. I'm not going to spend much on time on it. I'm just going to explain how it works. So this is how we write the test for home block, and then we are expecting this home blocks.stream to emit my title and my new title in that order. And then how this going to trigger? By calling this home block update title and home block this method again. Now you might be asking why we are using expected here before, why not we are using this after here. So the problem here is whenever we are using a basic Dart stream. So whenever we called update title here, is pass the event to the stream, but there was no one in the test to listen for that. So that item is missed. And when we expect that, at that time, we don't find that item in the stream and the test fails. So we need to have this expect before that, so that this emit in order waits for whole test to get the whole test execution should completed, and then it will catch all the items which were pushed to this title and then verify in that order. So if we run this test, this will pass because obviously I have copy pasted. So how it can fail? So it passed. Now I'm going to do same with a filter test here. So basically the filter test, I'm creating home block, I'm expecting the title in that order, and also I'm expecting a filter in that order. So I'm calling apply filter method here. I just need to import this. Apply filter method here with title and by the filter type. So it says that basically you need to update post stream. So if you're working with a primitive type and you are matching that in stream, it will match that. But if you are using an object to match in a stream, then you need to define some equality between those objects. Because let's say if you don't do anything, if you pass this Flutter today and you are expecting Flutter by today, it will fail because those instances of the object are different. So you need to set some equality for that object. So in here, I have set this equality operator here so that we can identify both objects are equal or not. And then if we run this test, it should pass. Now let's little more complicated block, label block. So label block is nothing but responsible for, I mean, let me go to the label block here first. So if you see here, we are passing a stream called label list here, which is responsible to populate this list here, and we have a flag called label.exist, which help us to whenever we are adding a label which already exists in the database, it will send true or false based on that. If it's true, we show an error, and if it's false, we just insert into the DB. And same with the color selection here. So we are not going to test this both. We are just going to basically test how we are emitting the list stream here. So let's just go back to the code here. And then I'm just going to write a list test directly here. So also one thing, in a label block, we are injecting the label DB here. So in unit test, we cannot test a real DB or real API implementation. We have to fake that. So we are going to fake this label DB, pass a dummy fake database here. And when we call this load label method, it's calling the label.db.getLabel method, which we are going to fake it and pass our dummy data to that, and we'll verify against that as a stream. So how do we pass that? We are going to create a fake DB here. I'm going to explain how we are going to do that. But before that, when we create a block with the fake DB, and we are expecting this label stream to emit test label 1 and test label 2. Currently, this will fail. This won't even compile because we have not created this. So let's just create this fake class. So basically, I'm creating a fake label DB here and extending to a fake, which is used from a Mockito library. And I'm implementing the class which I want to fake, which is a label DB here. So I'm faking that. I just need to import this list. And what I'm doing is I'm overriding the get label method here. And I'm just adding test label 1 and test label 2 if it does not exist in the list, and just pass that list as a future value. So this test 1 and test 2 which we are passing are here. So if I run this test, it will pass. So it passed, but if I pass another test label 3, it should fail because we are just mocking those two values. So this is how You can test multiple scenario using fake DB, and you can just change as per your test required. So let's get back to the slides. So unit testing, the advantage is it's blazingly fast, like the flash fast, and it is very less dependent. So you see, you don't require any emulator. It doesn't also require any UI widget related thing like parent widget dependency and all that. So because of all that, the maintenance cost is very low, and it's also a very good candidate for a TDD. So if you just creating a block, you can just create that using a TDD. And it's also provide a very fast feedback. So if you are changing something in the code, then if you run a test against that, it's very fast, and you understand you are breaking something or not very quickly. So the cons are the confidence is very less in terms of legacy code, because it's very tricky to write for a legacy code because the code is not structured in that way that you can start writing unit test. But once you started more integration tests and refactor it, you can write more unit tests. It's very less closer to the real user. You see, there is no there is no real user behavior matches on that block. It's just basically testing your business logic. And definitely the whole is greater than sum of its parts. And after the fact, the unit test consume more time. So after the fact here means if you already have a code base in the place, and if you want to write a unit test for that, it will definitely consume more time. So let's that's all about testing. Now let's see into some quick intro into CI/CD solution. I'm not going to go into much detail of that. I'm just going to give you an introduction so that you can choose and get started with, because there are many things to be done on a CI/CD solutions out there. So I'm going to talk about two things: Code Magic and GitHub Action. So Code Magic is my personal favorite because it's basically built for test mobile apps. Like the biggest pain in CI/CD for testing mobile app is just spinning up the emulator, running the test, closing the emulator, installing the app, and all that. So these things are already provided in a Code Magic. You don't have to manually do all that stuff. So first you need to sign up using your GitHub account, and then you can configure a build, basically Flutter app, Flutter widget, Flutter Dart package. You can even test the Dart package. You can even also test a React Native app in a Code Magic. Then this is how the Flutter configuration look like. You want to define the max duration of time, the build trigger here, sorry, the environment variable, deploying caching mechanism, your test, and all that. And this is how the whole report is generated, how much your test took, when was it started, and all that. So you see on the right hand side, you see the step which were used for preparing build machine, fetching resources, and all that. So these are the things are handled by Code Magic out of the box. You don't have to do anything manually here. You just need to define your repo URL and just start the build. It will do this everything for you automatically, especially building the artifact for Android, building the artifact for iOS, publishing, and all that, running the emulator, and also it will all be handled by this Code Magic. You can define a different build phase for how many platform you want to run on. Based on that, they can create what you can say artifacts for it. You can define a release mode for that, and define a release mode for that. You can just run a post script, also a pre-built script. Wait a second, just running into it. Okay, you can just define the test to run on it, enable test, Flutter driver test, stop build test. Wait a second, what is happening here? Okay, so you define enable Flutter analyzer test, and you can also select the emulator, Android emulator, iOS emulator. You can also define the AWS device farm where you want to fetch from it, and you can define the Flutter argument here. This is how the publishing phase works. Just release APK for code signing for iOS, email for set up the communication, and many other things. Now let's go to the second option, GitHub Action. So basically, this is an action tab on your GitHub repository. You can just get started with that. So this is how the folder structure you like. You need to create a github.folder/workflow folder, and that you need to create a YAML file, which will have the workflow defined. You can create a multiple workflow for your app. So this is our YAML file. Let's go step by step how we have defined. So we define an event on for what we are just want to trigger this. Currently, we want to push this for every commit we do, and just name that workflow. And we define a job where we define a build for this APK, and then we define this to be run on an Ubuntu latest. And then we define a step that first check out the whole repository. This action are defined in GitHub Marketplace and it's are available. And then you can use a setup Java while defining the version. So it will set up a Java version for you. Then there is a community build Flutter action package, which will you just need to define a version. It will fetch all the Flutter SDK for you. And then you need to run flutter.pub.get. Then you can run your Flutter test. And then you can build your APK. And then you can create your release APK using another community build action called release action. And you just need to define the artifact path based on path. And you just need to define a token. And based on token, it will upload to the Google Play. And this is how your action build will look like. So now we know how to write test. When we are going to deploy, we are going to be in this mode. So to summarize, first we understand why we need testing, because we need to have better user experience and a more confidence to refactor something. This both leads to generating more revenue. And then we see how can we get started with a zero test. We see in a standard-based approach, you need to have a more unit test because they are fast and cheaper to run. But it's very tricky to write in a legacy code base because the app is not structured in a way. So we write more integration tests so that it provides more test to real user. And then slowly we can just refactor our code and then move it to the writing more unit tests and reduce the number of integration tests. And then we have a demo for type of testing in Flutter with demo. Unfortunately, the integration test didn't run, but I hope I were able to explain it. It takes more time to run, but provide more real closer value to a real user. And then we run a widget test, which run like a unit test, but it has a lot of parent dependencies. And we also run a unit test, which for our block test. So we just test our business logic app, but we in a existing legacy code base, it's very hard to write. So we also talk about CI/CD solution like CodeMagic and GitHub Action. And these are some resources. And thank you.
Thank you. Thank you, Burhanuddin. It was really interesting topic. But unfortunately, we have no time for answers to our questions because we have only 2 minutes before next talk.
Okay.
But if it's possible for you, you can could you answer to questions in comments on YouTube?
Okay.
There is an interesting question about what state management solution is friendlier from the testing purpose. But we have to finish this talk. Thank you for listening us. Thank you, Burhanuddin, again. And waiting for you on the next talk in the 1 minute with half.
Okay. And thank you for the opportunity for taking the talk, for giving me opportunity here to talk.
Yes, thank you. See you. I think we will meet somewhere.
Yeah, sure. Hope. Okay. Bye.